Okay. Good evening. How are you? Okay. Yeah. Tonight we'll be looking at differentiation. In our last tutorial class, we did. Excuse me. We did limit, two of us. Okay. So this evening we are going to look at differentiation. Okay. If I may ask, assuming somebody just asks, what is differentiation? You know, when we say differentiation has to do with, differentiation means the opposite of what? Integration. You understand? And in history, differentiation has to do with changes. Either change time and order. Is that clear? So that is differentiation. All about, you want to know the change of, let me say, from now till so period, what will happen. If you want to know the weather of the growth, you understand, sometimes poultry, human beings, you understand. Let us just look at it this way, that assuming goats give birth to children, you understand. So if you want to know the growth of the birth rate, that has to do with what? Differentiation. You understand? Because at some point, the babies might lose their life. Some may survive, some might not what? Survive. You understand? All those to control the growth of living human being. It has to do with what? Differentiation. You understand? That is differentiation. So now, we want to look at it mathematically. I want to define differentiation mathematically. When we say differentiation, let us fix our idea with what is called function. If y, you have been given y equals to ax raised to the power of n, you understand? We call this dependent variable. This is known as dependent variable, right? Then we call this independent variable. Independent variable. Is that clear? Then this is called index or power. Then why this is called a constant. This is called constant. Amen. We call this a constant. Can you see now? So it is called a constant. It's called a constant. So that makes it a function. So this is a function. Ax raised to the power of what? N. This is a function. Is that clear? Yes. So sometimes the function could be in this form, either y equals to at raised to the power of what? N. You understand my point? Yes. So it means this function, this is y is a function of what? T. Then here, y is a function of what? X. Thank you. So if assuming you have something of this one, y is equals to ap raised to the power n. It means y is a what? Function p. Thank you. Is that clear? So let us look at it this way. Every one of us, we have parents, two of us. Yeah. So the reason why we bear our parents we are functions of our parents. You understand my point? That is why your name, let us look at it. Maybe your father's name is Peter. Can you see now? Then your name is, let's say, Emma. Emma. Can you see now? So if now we want to pronounce it, we pronounce it this way. Emma, Peter. Two of us. Two of us. So now, mathematically, if we want to pronounce this, because of this independent variable, because our parents are what? Independent. Two of us. Why you is what? Dependent. So it means you are the what? Y. It means this is how it will be. E equals to what? This is a man. This is what? Peter. Can you see now? So a man is the dependent variable, while Peter is what? The independent variable. That is why your name always sounds a man Peter. So if we want to put it mathematically, you always look at it this way. The E all over what? The P. Do you understand? So now, because of the independent variable here is what? X. So whenever we are to differentiate this function, we are going to be hearing the y all over what? The x. Why? Because the independent variable is what? X. Then, if now we want to differentiate this, it will always sound the y all over what? The t. Why? Because the independent variable is what? Then likewise, if we want to differentiate this, it will sound the left hand side will now the y all over what? Dp. Thank you. So let's move further to know differentiation mathematically. Is that clear? So now this is the function. Y equals to what? Ax raised to the power of n. So now the left hand side will now be dy all over what? The x will now be equals to, use this. This is the power, right? Yes. To multiply whatever that is here. Do you understand? Yes. So if we use this to multiply, we are going to have an x raised to the power of n minus 1. So this is the formula for differentiation. So as long as you know this, you are done with differentiation. Yeah, absolutely.
Is 1 n minus 1?
Yeah, minus, that is fixed. Now we'll fix idea with this. So whenever you are dealing with calculus, most especially differential calculus, you must know this thing offhand. Put it here. You understand? Just like you have defined what differentiation all about mathematically. Do you understand? So always put this here. Is that clear? You can write it down. You are done, right? Yes. So it means we can progress to consider examples. Do you understand? Okay. Let's. So now let us fix idea with example. That is why you always hear that. And another thing I want you to take notes. You understand? When we have dy all over the x, one can still rewrite this. This is still the same as y prime. It means you differentiated a function once. Is that clear? Or this is also the same thing as y dot. In physics, they make use of this. Then when you see d square y all over the x square, this is the same thing as or y prime prime. It means you differentiated the function how many times? Twice. So either they use this notation or this one. Or y dot dot. Do you understand? Then if you differentiate a function 3 times, this one means 3 times. Or this is the same thing as y prime prime prime, right? It means you differentiated a function 3 times. Or y dot dot, right? So this means you differentiated a function how many times?
3 times.
3 times. Do you understand? Okay. So now we can refer this as first derivative. This as second derivative. Then this as third. You can write it down here, derivative, so that if you come across all these things somewhere, do you understand? So now you know that this is d square y and d cube. Don't write it this way. Some of you want to write it this way. This and this and this are not the same thing. Please take note. Always take note. Is that clear? Because this is dy squared all over the x square. Why this is d square y all over what? X square. Yes. So now let's move further. Differentiate. So that is the definition of differentiation. It means it is what? The opposite of integration. That's the, so anywhere, anytime you are asked to find, to define differentiation, that is what you are going to do. Is that clear? So now let us fix idea with one example. If y equals to 2x raised to power 5, and they now say find dy all over what? Dx. Why did they say find dy all over dx? Because of the independent variable is what? Is x. True or false? So now we write solution to look at it. It means that y is equals to 2x raised to the power of what? We now come to this formula. We use this one now, two of us. It means your a here is what? Look at this function. We have a here. So a here is 2. True or false? Then our n here is what? Thank you. So it means the left answer will now be d what? dy all over the x is equals to, use the n to multiply what? 2. So 5 times 2.
10.
Thank you. So 10x raised to the power of what? 5 minus what? 1. Can you see now? So it implies that our final answer now dy all over the x is equals to 10x raised to the power of 5 minus 1. 4. Thank you. So that is why I said this formula must be here. So anything differentiation, we are using this formula. Is it difficult?
No.
Okay. Yeah. So let us mix idea with another example again. So you can now see that differentiation, as long as differentiation is concerned, you can tell somebody the answer. When you, okay, don't try to, let me just give you simple one. If y equals to 3x squared, okay, let's just make it this way. And they said find dy all over dx. Will it require you to solve before you tell somebody the answer? No, as long as you know this offhand, you can tell somebody the answer. The answer to this question is what? Yeah. No, it's 12. You use what to multiply 3 now?
I'm not going to minus 1. I know minus 1.
No, when you are multiplying, you are not going to minus it. You understand? You use this to multiply this. You are going to have what?
Yes,
12. 12x. Raised to the power of what? 4 minus 1. Yes. So it's going to be what? 12x raised to the power of 3. Two of us. Because our dy all over the x is equals to what? 12x raised to the power of 4 minus what? 1. True of us. So our dy all over the x is equals to 12x raised to the power of what? 3. Amen? Yes. So do you understand? Yes. That's it. We can take it down. Okay. That is that. Let me explain this. You are done, right? Yes. Okay. Now, let's look at this one. If y equals to 5x raised to the power 3, and you are asked to find y prime, you know y prime is the same thing as dy over dx. I mentioned it to you now. So, if you are asked to find y prime, do you need to solve this problem? You can tell somebody the answer, two of us. So what would be the answer for this problem?
15x. Raised to the power of 2.
Thank you. Can you see now? Yes. So it means our dy all over dx or y is the same thing as what? 15x raised to the power of what? 2. Is calculus difficult? No. The reason why it is difficult, you are not looking the calculus, you are not looking at it in this format. So if you look at most especially differential calculus, if you look at differential calculus in this format, calculus is not difficult. You understand? But just that people don't look at calculus in this form. They just look at calculus with empty brain. You understand? Because you must have this and look at it. So I don't think it will be difficult. Do you understand? Yes. So now, assuming we say if y equals to t raised to the power of 6, it means we have to differentiate this function with respect to what? T, two of us. Because the independent variable is what? T. Yeah. So it means it's going to be dy all over what? The t is equals to. Even this one too, you don't need a prophet to tell you. You don't need to carry pen and write. You can tell somebody the answer. Because here, the A here is an invisible one, two of us. So if you use this 6 to multiply whatever that is here, is it not 60? It's going to be what? 60 raised to the power of 6 minus what? Can you see now? So it means our dy all over dt is equals to 60 raised to the power of what? 5. Please don't write it in this form. Is that clear? You know, some people, instead of power, this is 65. There is difference between this and this. Please take note. It's very important. Is that clear?
Yes.
Write your 6 and t very well and the power boldly so that it will can be presented mathematically. Okay, you are done, right?
Yes.
So now let's look at this. Now let's look at it. If y equals to x, and you have to find dy all over dx. I know sometimes people get confused.
Yes.
Your answer, dy all over dx, we are still using the formula for what? Differentiation. Is that clear? So it means here there is an invisible one, true or false, which is n. Then here too there is an invisible one, true or false, as 1x, which is x, true or false. So it's going to be x to the power of 1 minus what?
1.
Can you see now?
How do we get 1 minus 1?
Yeah, already there is one. Invisible one is there now, true or false.
Yes.
But according to the formula, it means this is our n. Although it's not written like this, but you know that there is an invisible one here, true or false. So now, if you use this one to multiply this, it will still give you x. True or false? The rest of the power of 1 minus what? 1. True or false? So here will now be dy all over dx is equals to x raised to 1 minus 1. 0. X raised to power 0. Now you go back to indices. X raised to power 0 is what? 1. True or false? So our dy all over dx is equals to what? Can you see now? So have it in mind that whenever you differentiate x, or even if y equals to t, it will always give you what? 1. Take note. Is that clear? Those things, this type of things, you don't need to struggle to know them. But just put it at the back of your mind. Now whenever you differentiate t or x, it will always give you what? 1. Thank you. Yeah, please, I want you people to like and comment. I will be very grateful. Like and comment. Please. Okay. So that is that. So let us consider some examples. Okay. Yeah. So if now we have, if y equals to 2x raised to power 6 plus x, Eh?
Yes.
And you are asked to find dy all over dx, right? Okay. It's the same formula you use. So it means y is equals to 2x raised to the power of 3 plus x. Amen?
Yes.
So our dy all over dx is equals to, we apply the formula one after the other. Is that clear?
Yes.
So this is our a, this is our n, true of us. We use this n to multiply a. You are going to have what? 6, right? 6x raised to the power of 3 minus 1. True of us. What do we have here? Plus. Plus the same thing applicable. Note that there is an invisible one here. True of us. So if you use it to multiply x, you still get back x. So here is x raised to the power of 1 minus what?
1.
Do you understand? Okay, so it means our dy all over dx is equals to 6x raised to the power of 3 minus 1, 2, plus this is raised to the power 0, right? So x is raised to the power 0, then our dy all over dx is equals to 6x squared plus anything raised to the power 0 is what? Thank you. So whenever you differentiate functions like this, at the end you are going to have 1.
So that's the answer.
Yeah, that is the answer. That is the answer. Is it difficult?
Yes.
That is the answer. That is the answer. Okay. So let's move further to consider some examples. Are you done? You are done. I can play, right?
Yes.
Okay. So, assuming you have, maybe you are asked to, if y equals to c, then find dy all over dx. You can go ahead and tell somebody that this is 0. This is 0. You know why? The independent variable is what? X. But here is what? C. So this is a constant. So whenever, yes, it's a constant. So whenever, except they said find dy all over what? dc. That is when you can have 1. You understand? But this one they said find
C.
yeah. So c is a constant. This is a constant function. So it means if you differentiate this with respect to x, it means our dy all over dx is equals to what?
0.
Thank you. So you can write it down. Whenever you differentiate a constant, it will give you 0. Whenever you differentiate a constant, it
I see
will.
when you see that is a constant.
It could be any alphabet.
How do we know it's a constant?
Yeah, don't worry, we'll be there. We'll be there. So whenever you differentiate a constant, it gives 0, right?
Yes.
Okay. So now let us look at quadratic functions. Now, let's look at quadratic functions now. If y equals to ax squared plus bx plus c, looking at this function, do you need a prophet to tell you that there's a constant there?
No.
You don't need a prophet. Why? Because here, A, x is attached to A. B, x is attached to B.
Yes.
But it's only C that the x is not attached to, true or false? So it means this is a constant. So bear it in mind that if you differentiate this function, this place will be what? 0. Do you understand? So now it means our dy all over dx is equals, what do we do? This is our n, right? This is our a and a, right? So this times what? So it will be 2ax, isn't it? Raised to the power of 2 minus 1 plus b. This is here is 1 times b is b, bx. Bx raised to the power of 1 minus 1. So you can now see that anything we are doing, we are what? Applying what? The formula, true or false. So dy all over dx is equals to 2ax, 2 minus 1. It's not necessary you write it. But if you say you want to write it like this, no problem. You understand? But it is not necessary. Then what is there? Plus, right? Then bx. Thank you. So anything raised to the power 0 is 1. So 1 times b. B. So our dy all over dx is equal to 2ax plus b times or dot 1. Then if you multiply, our final answer will now be dx is equal to 2ax plus b. Is it difficult? But sometimes, depending on who is teaching you, it depends on who is teaching you. Please, I want you to like and share. I'll be very grateful. I want you to like and share. I'll be very grateful. Can we proceed now, right?
Yes.
Okay. So, okay, let's look at this function now. Assuming you are asked to, if y is equals to 2x, do you need to solve this problem and tell somebody the answer before telling somebody the answer? No. You don't need to solve this problem or carry pen that you want to. You can tell somebody this answer, two of us. Eh? As long as the formula, you are using the formula. This answer, you can tell somebody the y over the x is 2.
The answer is 2.
Yes. Look at it here now. It's the same thing with this now. Look at it now. True or false? It's the same thing. Look at it now. Look at it. Find the y all over the x. Look at it. Our dy all over the x is going to. We have this visible one here. Use it to multiply 2. Is it not true? So it's going to be 2x raised to the power of 1 minus what? True or false? So it means our dy all over the x is equals to 2x raised to the power of 1 minus 1. It's 0. But it's true. True or false? So, okay, assuming you are asked to differentiate this 5x, what is supposed to have? They said find dy all over the x. What do you supposed to have?
5x raised to the power of 0.
Is what?
Is 5.
5. But always bear it in mind that dy, always call dy all over the x, is equal to what? 5. Don't just say 5, because in the exam, you just look at it, the answer is 5. So what does this 5 mean? You have to show that. It means, because they ask you to differentiate with respect to us. So this is what you should write. You understand? Are you following?
Yes, sir.
Yeah. Any questions so that before we then okay, what if you are asked to if y equals to minus 16 and find dy all over dx, do you need to carry pen and write? What should be the answer?
Minus 16x raised to the power of 2.
Yes.
That would be minus 16.
Yeah. So is calculus difficult?
Yes.
No. You can now see that since all this while we have been making use of what the formula. So it means that formula must be here. So if you don't put that formula here, if they give you a function to differentiate, you just be looking like as if somebody who has not attended calculus class. It's because of you don't put the formula here. So the formula is very important. So all this while we have been doing this, that is the formula. Is that clear? You know, sometimes if they want to confuse you, they may say if y equals to 14x raised to the power of 0.5, then find dy all over dx.
Yes, sir.
If they want to confuse you, they just want to confuse you. I'm going to open your eyes. Look at it. This one has involved fraction. True or false? Yeah. This one has involved fraction. So what you need to do here, don't be panic. I will open your eyes. Amen?
Yes, sir.
So solution, our y is equals to 14x raised to the power of 0.5. You know that 0.5 is the same as 1 all over 5.
Yes, sir.
True or false?
True.
Or you first start with 2 all over what? 10. You understand?
Yes, sir.
So 2 to itself 1, 2 to 10, 5. You can now see that 5 all over what? 1 all over 5. So it means this function, instead of 0.x raised to plus 0.5, you now convert it.
But how can we get it easily?
Yeah. Most especially since we have 0, 5. So it means we are talking about tenth. You understand? So it must be, how am I going to explain it for you to understand it better? You know that 2, if 2 divides 10, this will give us 0.5. So likewise,
Okay, yes.
likewise, this to this, this to this. It means 2 all over 10 is the same as 1 all over what? 5.
How can we know if we
Then-
can calculate or
Then this is the same as 0. That is where your thinking faculty will be very fast. You understand my point? Your thinking faculty. Okay, sometimes we may say 0.4. 0.4. Let's think of 0.4. 0.4. Uh, 0.4. 1 all over 4.
that's what it will be.
That is what it's supposed to give you. True or false? 1 all over 4. So let's fix idea with this. Okay, so now it means here, instead of 0.4, we what? Write,
1 over 5.
thank you. So it means this is our n.
Yes.
So now our dy all over the x is equals to, use this to multiply. You are going to have 14 all over 5 x raised to the power of 1 all over 5 minus what?
Minus 1.
Then you have to look for the LCM.
Of minus 1.
No, 1 all over 5 minus 1. The LCM now. So now what you need to do is, this is, write it this way, 1 all over 5 minus 1. Make sure there is an invisible one here, right? So here, what can divide 5 without a remainder and 1 is 5. Or the fastest method of looking for LCM, use this one to multiply this, use this to multiply this, then this to multiply themselves. Is that clear? If you don't want to think much. So 5 times 1,
That's 5.
5. But let's first start with this one. 1 times 1.
1.
Thank you. Then what do we have here? Minus. Minus. 5 times 1.
That's
5. 5 times 1.
5.
5. All over what? Can you see now? So here, 1 minus 5 minus 4. Minus 4 all over 5. So it means our final answer will now be our dy all over the x is equals to 14 all over 5 x raised to the power of minus 4 all over 5.
Now why won't we break the answer down?
Break it. This cannot divide now because
Okay, you can divide your x.
again you can break it down. But I will advise you to stop there. Is that clear? But if you say you are strong mathematically, you want to break it down, no problem. Is that clear? Thank you, Sojourn. Thank you. You are welcome. Well, may I know where you are watching me from? Sojourn. Where are you watching me from? Yeah, boy, let me know. You are watching me from Nepal. Which country? Are you watching me from Italy? Okay, let's move further to consider more examples, right? Okay. Yeah. So now we have some examples here. Now we have some examples here. If y equals to 5x plus 5x squared plus 3x minus 2, find dy all over the x. Okay, so we write solution. Our y is equals to where is this? Okay, y is equals to 5x squared plus 3x minus 2. Already, you know that this is 0, two of us. Why? Because it is what? A constant. So what you after is this and this. Two of us. So our dy all over the x is equals to, use this to multiply this. 10x raised to the power of 2 minus what? 1. Right? Then what is here? Plus. Then 1 times 3. 3x raised to the power of 1 minus what? Can you see now? This is what? 0. Two of us. So our dy all over the x is equals to 10x raised to the power 1, then plus 3x raised to the power what? 0. Then the final answer will now be dx. All of dy all over the x is equals to 10x plus what? 1. This is 1 now. All in bracket 1. You want it this way. But already it's 3 now. Two of us. It's not necessary. If you want it this way, no problem. So it means our dy all over the x is equals to 10x plus what? 3. Do you understand? Yeah. You can copy it. Take it down. Oh, Nepal is a country. Something like this. Are you serious? This is my first time. So, how is Nepal? You are welcome. Nice meeting you here. Thanks for watching me. I would love to meet with you. If you don't mind, just drop your email address here. I would love to meet with you. Just drop your email address. I'll chat you up. Soja, I'll be grateful if you share your email address with me. Yes. Let's try functions like this. Let's try functions like this. If a equals to 2 all over t raised to the power 2, then plus 5 all over t minus t raised to the power minus 1. And you are asked to find the a all over the t. You can now see that both the dependent and independent variables, they changes, two of us. This one is a, not y. This one is what? T. Two of us. Okay. So before you will be able to solve this type of problem, I'm going to show you how you will do it. That way, when you come across questions like this, minus 2t raised to the power of 1. When you come across questions like this, it is not difficult. It is not. Yeah. Look at it. Before we begin to solve this problem, let me show you something. Is that clear?
Yes, sir.
As it is, since differentiation is strange to you, and it's your first time of coming across functions like this, you find it difficult, two of us. So now, when you have something like this, go back to your indices. Go back to your indices. If we have 1 all over a, we can still rewrite this a raised to the power of minus 1, two of us. So it means if we have 1 all over t, it means we can rewrite this t raised to the power of what? Two of us. Then if we have 1 all over t raised to the power 2, it means we can rewrite this in this form, t raised to the power of minus what? 2. Do you agree with me? Okay. Then what if we have assuming 1 all over t raised to the power of 5? It means we can still rewrite this t raised to the power of minus what? So you should take note of all these things. So you see where your indices is applicable. We are applying indices in calculus. Can you see now? And that is the reason why you were taught indices in the first semester before now, three of us. Yeah. So we can now proceed to consider this function. So it means here we are going to a is equals to 2t raised to the power of what? Minus 2. Thank you. Now what do you have here? Plus here 5t raised to the power of what? Minus 1. Right?
Yes,
Minus 1, then minus 2t raised to the power of what? Minus 1. Can you see now?
yes.
Okay. If you can see what I am saying,
Yes.
we can subtract this because they are the same thing. Just like 5 minus 2 will give us what? 3. Two of us. So here we are going to a will now be equals to 2t raised to the power of what?
Minus 2.
Then plus 3t raised to the power of minus 1. We are still going to use what? The formula. Is that clear?
Yes.
So here, if we are to use the formula here, the n here is what?
Minus
Thank you. The n here is minus 2. But it means we are going to differentiate this function with respect to what? T. So the a all over the t will now be equals to minus 2 times 2.
minus 4.
Thank you. Minus 4t raised to the power of minus 2 minus what?
1.
Amen?
Yes.
Then minus 1 times 3.
Minus 3t.
Thank you. So minus 3t raised to the power of minus 1 minus 1. Can you see now? So this implies that our dA all over dt is equals to minus 4t minus 2 minus 1 minus 3 minus 3 minus 3t minus 1 minus 1 minus 2. We leave it like this, or we can come back here. We can still transform it this way, or this is the same thing as dA all over dt is equals to minus 4 all over t raised to the power of 3. Can you see now? Then minus 3 all over t raised to the power of what? Either you pick out of this, you pick one of
Ask
this.
a question.
Yeah, ask.
Particularly the powers,
Yeah.
they are carrying minus sign, but when we change it to another form, they drop the minus.
Okay, look at it, look at it, look at it, look at it. When you see something like this, this is 1 all over what? Thank you. This is 1 all over t. It means this is the inverse of t raised to the power minus 1 is known as what? 1 all over what? T. That's the inverse. Do you understand? So that is why you remove the minus sign. Immediately it comes down. But if you bring it up, it will now carry negative sign. Is that clear? So take note. Then write it down. Okay. So now let's move further. Let's move further. So now, now let us. All these ones I've been doing. I'm just teaching you how to differentiate direct. You understand? So now we want to go into rules for what? Differentiation. Is that clear? We want to go into rules for differentiation. So if you can understand each of these rules, I don't think you have a problem. Anything called differentiation. With what we have done so far. Is that clear? Okay. So now, I want you to take note of this. If assuming they give you function like this, square root of t, and you are asked to find dy all over what? The t, right? As it is, you cannot differentiate this function, two of us, except you transform this. So you should take note that when you have square root of t, this is the same as t raised to the powers of 1 all over what? 2. So it means you transform this in this form, t raised to the powers of 1 all over 2. So you just differentiate it. So this is your n, two of us. Use it to multiply. Then it means our dy all over what? dt will now be 1 all over 2t raised to the powers of 1 all over 2 minus what? 1. Two of us.
So usually the 1 over 2 twice. Why do you appear twice?
That? Is that?
Why do 1 over 2 appear twice?
Why? This is the n now. 1 all over 2 is the n now.
Yes.
So you are using this n to multiply whatever that is here.
Okay.
The two of us. So here you do the LCM. You are going to have minus 1 all over 2. That is what you will have. So what we want to consider is rules for what?
Yes.
Rules for differentiation, right? We want to consider rules for differentiation. Rules for differentiation. Rules for differentiation. Okay. Now, we are going to consider the rules for differentiation. One of the rules, we have 3 rules. 1, product rule. 2, quotient rule. And 3, they call it chain rule, stroke substitution, either stroke substitution or we call it function of a function. These are the 3 rules guiding what is called differentiation. So these 3 rules will direct you when to differentiate a given function, how to differentiate this function. You understand? So if now you know all these rules, it means, excuse me, differentiation won't be a problem. So we'll consider one rule, then do one example, and we'll call it a day. Is that clear? So let us consider product rule. Product rule. Let's consider product rule. Product rule. Products. Let's go back to mathematics, our elementary mathematics. JS 1, 2, 3. What do you mean by product? Yeah, product means multiplication of times, true or false. So it means that, this means that, as long as differentiation is concerned, if 2 functions multiplying each other, you can apply product rule. So it means this is how it is. Y is equals to UV. You can now see that this is a function. This is another function, true or false. So you can now see that 2 functions are multiplying each other. Isn't it? Yeah. So the formula is our dy all over dx that will equals to u dv all over dx plus v du all over what? Dx. This is the formula. Or sometimes, some textbooks, it's the same thing. Either you use this one, sometimes some textbook, this one will come first, this one will now be at this side. That is commutative. So it means v du all over what? Dx plus u dv all over what? Dx. Can you see now? Just like somebody will write a plus b, then somebody will now write b plus what? A. You can now see that this and this, they are all the same thing, true or false. So don't get confused. Is that clear? They are all the same thing. You can write down this thing so that we fix idea with one example. Yeah. Now we have this. Let me place the side. Example. If y equals to x plus 1 and x minus 1, then the now say find dy all over what? Dx. Can you see now? You can, if you can see what I have seen, look at it. Because they will not tell you to use product rule. It is left for you to what? Identify whether this function, is it product rule that I will use so that I will not have issues. You understand? So when you come across functions like this is one function, this is another function, and you see that they are multiplying each other, two of us. Yeah. So what will first come into your mind is for you to apply what is called what? Product rule. So you now write. Say solution using the product is very important to any rule you are using. The product rule. Right? Then you write the formula. Our y is equals to uv. So our the y all over the x is equals to either, if you want to use this one or use this one, whichever way. Yeah? Any one, you are correct. So let's use this one. V the u all over what? The x plus u the v all over the x. Some textbooks, they use this one mostly. Yeah. So now, as it is now, this is the function. Y equals to x plus 1 and x minus what? 1. So let us ask ourselves, as it is, y equals to uv, do you want a prophet to tell you that this is your u, this is your v, compared to this? So which one is supposed to be your u?
X plus 1.
Thank you. So you now see, let u be equals to x plus 1 and v be equals to what? X minus 1. Amen? Okay. So now, you can now see that in the formula, we have our ordinary v, we also have our ordinary u, two of us, which we have gotten it, this and this. But in the formula, we also have the u all over the x, and we have the v all over the x. But we've not gotten this, two of us. So it means, how are we going to get this? It's for us to differentiate these functions with respect to x. Differentiate this one with respect to x. You can see that we obtain our du all over the x. So let us differentiate this. So if we differentiate it, du all over the x is equals to, here we are going to, this is a constant, two of us. This is 0. If you differentiate x, what are you supposed to have? 1, isn't it? 1. Then the same thing, and the v all over the x is equals to, this is a constant, already is 0. If you differentiate x, 1, thank you. 1. So now we substitute this answer into what? This formula. Is that clear?
Yes.
So it means our dy all over the x now, this is ordinary u, v. What is ordinary v here? X minus 1. Then this is the v all over the x. What is the v? The u all over the x is what? 1. 2 of us times 1. What do we have here? Plus. Plus. Then what is our ordinary u?
X plus 1.
Thank you. X plus 1. Then what is our v all over the x?
It's 1.
1. Can you see now? This is up. You are done. But if you say you want to expand the bracket, no problem. So we can go ahead and expand the brackets. 1 times x is x. 1 times minus 1, minus 1. Two of us. What do we have here? Plus 1 times x, x. 1 times 1 is 1. So you can now see that this and this will cancel, isn't it? We'll be left with our dy all over the x is equals to x plus x, which is what? 2x, isn't it? So our final answer will now be dy all over the x is equals to 2x. Okay, gentlemen and ladies, thank you for your time. I'm very grateful. Hopefully, same time, I will be live tomorrow. If the weather is okay, friendly. Sometimes here, rain, every storm. With every storm, will come and interrupt. So I may not be live, because of the network, poor network. So thank you once again for your time. Please like, comment, and share. See you guys. Love you guys. Bye.